Okay, today we're going to look at absolute maximum and minimum values. And we've kind of looked at maximums and minimums before, but it's important to note that when we're talking about the absolute maximum and minimum, what we're talking about is the absolute maximum is the highest possible value that can come out of a function, and the absolute minimum is the lowest possible value. And it's really important to note the difference between local maximum and minimum versus absolute maximum and minimum. And often they are two separate things. Okay, so let's just see if we can get an idea of what that's actually saying. We've got a function here, this cubic function. And what we're noting is that the local maximum is -1, 5. That's the local maximum. And the way I kind of think about this with my vivid imagination is it's like the sheriff in movies or something like that. And what it basically the sheriff is saying is around these parts, I am the highest value around these parts. And like that's arbitrary where I've drawn that, like around these parts or whatever. But locally, I am the largest value. Never mind the fact that the function tends towards infinity as x approaches infinity. I am the largest value around these parts. And same goes for the minimum. You know, the sheriff would be saying, hey, I'm the lowest value in these parts, never mind the fact that we tend towards infinity here. So the absolute max of this function here is infinity. The absolute min of this function here is negative infinity. All right, let's look at this problem here. Now what we've got is a cubic function. It's not the same one, is it? Yeah, it's the same function. Just we've got a restricted domain. And we note here that the local maximum is still not the absolute maximum. The absolute maximum is given by f of what looks to be 2.5. Yeah, 2.5, because that's the domain. Equals whatever that is. It looks to be 11 or so. I'm not going to check it, but whatever that value is, that's going to be the absolute maximum. Now, the absolute minimum isn't actually given by the endpoint. Really common thing students do is they just slam in two endpoints. Lowest value is the absolute minimum, highest value is the absolute maximum. But in this case, the endpoint here is actually not the absolute minimum. The absolute minimum is actually the same as the local minimum. So here the local minimum is also the absolute min. All right, so let's see if we can apply that in a few different scenarios. All right, so what is the absolute maximum and absolute minimum of this function over the domain -1 to 3? All right, and let's consider this is no-cas or exam 1 style. Okay, so how are we going to do it? Well, the first thing you absolutely have to do, is sketch the function. Okay, you've got to get an idea of what this function looks like. So we've got an intercept at 0, -1, and 1, and it's going to be a positive cubic. So it's going to do something like this. So here's -1, so let's chop the function there, and we'll put our endpoint there. And let's note that this is 1 here, so 3 is going to be over here, and it's going to be somewhere up here. All right, so what we can see fairly quickly is that even though this endpoint here, -1, wasn't included, we don't even need to worry about this endpoint here because the absolute minimum is going to be the local minimum. The absolute maximum is going to be whatever f of 3 actually is. So let's get started on it and do f of 3 for a start. So let y equal f of x equals x take 1. Whoa, what am I doing? X take 1, x plus 1. And then we're going to do f of 3 equals 3, 2, 4, 6 times 4, 24. So the absolute maximum is 24. Okay, so that's the easy part. Now, the harder part is to work out what the absolute minimum is. And for that, what I need to do is work out the x value for which the stationary point occurs and slam that x value into the function. Right, so how do we find stationary points? Well, what we do is we get a gradient function and let the gradient function equal 0. So let's just do that. So I'm going to say that f of x equals x times, now this is just difference of perfect squares, so that's x squared take 1 equals x cubed take x. So that means that f dash x is going to be 3x squared take 1. 0 equals 3x squared take 1. 1 equals 3x squared. X squared equals a third. X is equal to plus or minus 1 over 3. Okay, so obviously the negative version of that is this one here. So we're going to say, but min occurs at x equal positive 1 over 3. So we're going to do f of root 1 over 3 equals. So what we've got to do is slam that into f of x. So that's going to be, so we'll put it into here. So it's going to be 1 over root 3. So I'm just going to root the 1 and root the 3. And we're going to raise that to the power of 3. Take away 1 over root 3. All right. Now, that's the value. It's that there. That's the absolute minimum. Let's go ahead and see what the calculator says on this. And I'm sure that it's going to be able to simplify that. So let's just see. This will be a good exercise. X times x take 1 times x plus 1. Let's diff it. Solve. And we'll do f of this value here. Done that. Let's just simp it. Okay, so they've got negative 2 root 3 over 9. So let's just see how they did that. This will be a cool exercise in, in practicing our simplifying. So this is going to be 1 over 3 to the half all to the 3. Take away 1 over 3 to the half. This is going to be 1 to the power of 3 is 1 over 3 to the half to the 3 is 3 to the 3 on 2. Take away 1 over 3 to the half. Now what we're going to do is times this by 3 and times this by 3, or 3 to the 1. Now why do that? Well, we've got a common base here. That'll add the power, and that'll give us our common denominator here. So we're going to do 1 take away 3 over 3 to the 3 on 2, which is equal to negative 2. Now, what we're going to do is split this, so 3 to the 3 to the half. So 1 power raised to another power, multiply the powers. So that's negative 2 over the square root of 27. So 3 to the 3 is 27, to the half is the square root of 27. Now we're still after this, okay? So let's just see what else we can do. Negative 2 over root 9 times 3. Root 3 is 3 root 3. And then when this gets rationalized, we're going to go root 3 over root 3, which is equal to 3 times 3, which is over 9, negative 2 root 3. Oh, there it is. So yeah, talk about further engagement. So yeah, my feeling is like on a by hand part of the the exam, there's no way you can leave the answer as that. You've got to further engage. So here's how we do it on the calculator. So I know Ms. Cowan doesn't use Fmin or Fmax. That's not a criticism. You know, each to their own. I don't mind it. And for a problem like this, if it's tech active, it will be very quick at feeding you the correct answer. But I don't know. I can't see it coming up in an exam as a one marker. That's just too easy. You just chuck it into the calculator. So I'm with her. I reckon the function's not that great, but you never know. It might come in handy. It certainly comes in handy at other parts or in other parts. So a reminder that what you do is you define the function and you go to calculation. And what we want to do, we've got the maximum already. We just want the minimum. And so you say, hey, the function in question is f of x, the variable is x, and I'm going to give you this restricted domain or this search coordinate from -1 to 3 and get it to go and grab it. And there it is there. We can see we went the long way there. Fmax just slams it out. Okay, so it is a very efficient way of doing problems like this. But again, I seriously doubt that like it's going to be, you know, just as simple as that. All right, here we go. We've got another problem here. Find the absolute minimum and absolute maximum for the cubic over this domain to 2 decimal places. Okay, let's assume this is a multiple, say 4-mark question and tech active. All right, that's great news. Okay, so what we're going to do is say let f of x equal 2x cubed take 6x squared plus x. Let's diff it. Let's not diff it. Okay. What are we going to do now? Well, I think we should get an idea of what the function looks like. So my first thought is that we should solve it. 0 equals 2x cubed. Take away 6x squared plus x. 0 equals x. 2x squared takes 6x plus 1. X is equal to 0 and x is equal to this. That's going to be quad formula. So negative b is 6 plus or minus the square root of b squared, which is 4. No, it's not. It's 36. Take away 4 times 2 times 1 all over 2a, which is 4. X equals 6 plus or minus the square root of 36 take 8. What's that? That's 28 over 4. X equals 2, 3, and this root 28 is going to be root 4 times root 7, which is 2 root 7, and we're going to cancel the 2 on the simplify. So we're going to get 3 plus or minus root 7 over 2. Okay, so there are our x-intercepts. Okay, so we've got 1 at 0, 1 at 3 minus root 7. Now, it's good to know what root 7 is, and I know what this is tech active, but you should know that root 7 is less than 3. So that's really important to know. Okay, so root 9 is going to give us 3, root 4 is going to give us 2, so root 7 is 2 point something. All right, doesn't really matter what something is, it's 2 point something. So this one here is going to be your first x-intercept, which is 3 plus minus root 7 over 2, and the next one's going to be 3 plus root 7 over 2. So what my cubic is going to do, and the scale is just shocking here, girls. So like, you know, I'm not going to sort of deny that, but our cubic is going to look something like this. Right, so now we have a look at our domain. So we've got like -1 is going to hit a value down here somewhere, and that's included, and 2.5. Well, 2.5, where would that be on this? That is 3 plus 2 point something, which is, let's just say it is 3. That's 3. 3 plus 3 is 6. 6 over 2 is 3. It's going to be a little bit. 2.5 is somewhere around about here. All right. Don't know exactly where. All right. So we can see here what our absolute maximum is going to be is this value here. What our absolute minimum is, and I wouldn't be judging my scale as the certainty, it's either going to be this min here or this min here. Now we don't know what that min looks like. The function could actually look like this. I'm going to change my color here and just show you. It could come through there, up, and then do something weird like this. Cubic's kind of like, I find it hard to predict where that stationary point is, and that might trump whatever this one is over here. So we can't say with any certainty. So what I want to know is, what is the lowest value? Is it going to be here or is it going to be here? Okay. So let's crack on with the task at hand. Well, what color was I doing that in? Yeah, that looks similar. Okay, so we're going to say that max, so absolute max occurs when x is equal to, it's this stationary point here, okay? So we're going to say, no, let's not write that. Sorry if you've written that down, pause the video and grab a rubber. So what we're going to do is actually diff this cubic function to work out the x value of that stationary point and then slam that into the original function. So to do this, I'm going to do f dash x equals 6x squared take away 12x plus 1. All right, that's quad formula. That's going to involve putting something ugly in. So I'm just going to say 0 equals 6x squared take away 12x plus 1. And for the first time in this question, I'm going to head over to the calc here and find my original function, 2x cubed take away 6x squared plus x. I'm going to diff it. I've already done that, but solve answer equals 0 for x. Okay, so there's my stationary points. Now, the lower one, this one here, that's going to be this one here. So if I do, let's write it down. So we're going to say that x is equal to plus or minus root 30 on 6 plus 1. We're going to say that absolute maximum occurs at x equals, so it's a negative version of negative root 30 on 6 plus 1. So we're going to do f of that value, f of this thing here, and it's going to give us the absolute maximum, which looks a lot nicer after a simp. So f of negative root 30 on 6 plus 1 equals 5 root 30 over 9 take 3. And let's just make sure that whoever's marking knows that this is the absolute max. All right, so there's our absolute maximum. So that occurs at this point here. Now, what do they want? The absolute minimum, absolute maximum to 2 decimal places. Oh, that's shocking. But anyway, so now we've got to approximate that. So decimal, so absolute max is equal to 0.042, 0.43. Why are we approximating? But anyway, it wants it. So there's our absolute maximum. Right, we can pretty safely check this as well with Fmax. for f of x. And can we search between -1 and 2.5, please? There it is. Okay, so that's good. All right. So the maximum value is that amount there. Right, now, again, why didn't I just do that? Say this is a 4-mark question. I can't just go because Fmax told me. Okay, we've got to actually show some method to obtain this value. Right, so where's the min? Well, the min is going to be either there or there. So let's find out on the calculator. So it's going to be either f of -1, which is -9, or it's going to be at the other stationary point. Now, I don't know. I know my graph looks like that's way lower than that, but again, cubics can take some unusual turns, and this turning point might be much lower. So let's find out how low it is. So I'm just going to grab this one and stick it in there, and oops, and get it to calculate that. So it's -6.04. Okay, so it was a close competition. It was either -9 or -6, but obviously this is the lower value, so that's going to be the absolute minimum. Okay, so I'm just going to comment that. So absolute minimum occurs at x equal -1. Don't really need to justify why it's not at the stationary point. So I'm going to do f of -1 equals -9, which is the absolute min. Right, so there it is. Not easy, and especially if you're going by hand, that's a fair bit of work there to go through. So good practice to just go through the steps there rather than use Fmax and Fmin to spit out the values. Let's just make sure that it was -9, so I'm just going to change that to min. Yep, -9 was indeed the correct answer. But yeah, don't just use Fmax and Fmin doing your homework. That just throws out the numbers and you copy it down. You want to actually get into the practice of like sketching the graphs and trying to work out, is it the stationary point, is the local max, the abs max, etc., etc. Okay, so there's the homework there for 10E. So get that done. And as always, let me know if you've got any questions.